Alright, unfortunately, there isn't like an app or something where I can also record the calculator. Or at least I don't have at the moment. Um, so yeah, we're just gonna survive by just talking about it. Okay. Log x 4 equals 2. So now for this thing, when you have to solve for x, basically think of it as um, where you want to put it on the other side. So like log x just means that x is on the bottom, 4 and 2. Like you have the available exponents of 4 and 2. So what we want to do is we want to transfer the x to the other side, which would put 4 and then x on the bottom over 2. So it's basically just going to always be like a bottom number, and then the top, and then whatever number it'll be next to, that number will be the exponent. So basically then you can square it and you have 2 equals x. That's the answer. And now you might get a plus minus answer, but you'd only use the positive number since you can't have the negative. Okay, so now here too. See how it says log 6? So basically this log is just like a fancy way of saying keep the 6 in the bottom wherever you put it. So x we're going to keep here, and we're going to bring the 6 over. And since 6 to the power of 0 is 1, x will equal 1. Anything to the power of 0 equals 1. Okay. Now we're going to use our knowledge of inverses to graph the following functions. So basically, when you have f of x equals 2x, by the way, you can also just use your calculator to find out all the numbers if you can't really think about it right now. So basically, let's set up our table. And we're going to write -2, -1, 0, 1, 2, 3. When writing the x's, you don't really have to calculate anything. You just go in order. I would recommend starting at either -2 or -1. And she wants at least 5 numbers, I think she said. Here we have 6, but whatever. Okay, and then so -2, so 2 to the power of -2 is 1 over 4. And then 2 to the power, since you see how that's the function, and then x, this is whatever x equals. So x equals -1, x equals 0 for each thing. So we're going to go down here to where x equals -1. So 2 to the power of -1, since we're replacing x with -1, is 1 over 2. And then 0 to the power, so 2 to the power of 0 is always 1. 2 to the power of 1 is 2. Then there's 4, 8, so on and so forth. And then we can graph it over here. So let's start off with our vertex being 0 and 1. Okay, let's start a little before that. So we'll -1.5 right there. And then -2 in the quarter right there. It doesn't have to be exact. And then 0 and 1, 1 and 2, 2 and 4, 3 and 8, 7, 8, and there. And then we could just draw our line with this one. Okay, and then when writing the inverse, it's pretty simple. You can just replace the y and the x. So x will be whatever the y equals. So like, see how over here y is 1 over 4, so that's where the x will be, 1 over 4, 1 over 2, 1, 2. So we're basically just flipping it around. And see how x over here equals -2, now we're putting that on the y side. -2, -1, 0, and that's basically how every function, like every inverse works when you put it on the graph. Like when, yeah. Okay, so now we can graph this. So quarter and -2. So again, it doesn't have to be exact. I doubt she's gonna be, she cares. So there, 1 and 0, that is our vertex. No, might be our no, it's not. I don't know, whatever. 1 and 0, 2 and 1, and then 4 and 2, 8 and 3. See how it's like significant, like it's like very different from the other. Okay, and by the way, there's also a line arrow here, and those are your things. So yeah, by the way, I'm pretty sure it won't actually ever touch the x equals 0 line, or over here the y equals 0 line, because like we learned this thing where it always goes just about close, but it'll never touch it. Yeah. Okay. Now number 5. Solve for the following logarithmic equations. So log 3 2x plus 3 equals 2. So log base 3, I guess. So basically, we're gonna take this 3 out, so that there, and then we're gonna put the 3 in the bottom of this 2. So we have 2x plus 3 equals 3 to the power of 2, which is 9. And then we can get rid of that 3 equals 6, x equals 3. That's the answer. Awesome. Okay, log x 81. So now we're going to take the x here, sort of put over here, x to the power of 4. So 81 equals x to the power of 4. And then we're going to do both sides by 4. And as we did before, 3 to the power of 4 equals 81. You can also do that on your calculator by going on math and then scrolling down to where it says log base, and then you can fill in the different things. Yeah. Oops. All right. And shoot. All right. Okay. And yes, you have 3 equals x, and that's the thing. And also you would have a plus minus, but you only use the positive number. Yeah. Now we have log base 2 x squared, so we're going to take the 2, cross that out. 2 to the power of 4 is 16. X squared plus 16, x squared plus 6x equals 16. And now we're going to do the equals 0 thing. X squared plus 6x minus 16 equals 0. And then what adds to 6 and multiplies to negative 16? 8 and negative 2. So x plus 8, x minus 2. And then you get x equals negative 8, because remember, when we put the x equals, it's always the opposite symbol. And x equals positive 2. And those are your 2 answers. And you can both check it by just plugging it back in for what x. Like, you replace the x with negative 8, replace it with, and then for the next x equals 2, you can plug it in for 2. Okay. When you see an expression like log 3, what is the base? The base is always 10. If you don't see a base, if it's not log 10, log 9, 3, in this case the base would be the 9. But when there's no base shown, it's always 10. Always. Use the properties of logarithms above, the properties in the box, to write the following expressions as sums and differences of logarithms. So there is no properties of logarithms above. So what we're going to do here is I'm going to pull them up to look at them, and I'll explain them. What is the property of logarithms? I will come back to number 7 in the next video because I have to also, whenever we do logarithms, wait, unless is the end everything here logarithm, property of logarithms? No. Okay, so yeah, so I'll go back to those in the next video when I learn how to do them. Okay, how would you evaluate log 2 6? This is also a bit of the property of logarithms, but just know that when you have a power rule, no. How would you evaluate log base 2 6? So you'd put this top number on the top of the, you'd put it into like a fraction. Top goes on the top of the fraction, bottom goes in the bottom of the fraction. So you have log 2 log 6. And that equals 2.58. Because when you put into your calculator, when you put log 6 over log 2, that equals 2.58. Okay, and same thing for all these. Top goes on the top, bottom goes on the bottom. Okay, 8. How would you plug something like y equals log base 3x into your calculator? So you'd plug it in again, but top in the top, bottom in the bottom. Y equals log x log 3. Awesome. And by the way, don't get confused here. You still would put log 10 on the bottom. You wouldn't put log nothing. You'd have to put log 10, I think. Okay. Solve the following logarithmic problems. 4 to the power of x equals 7. So we're going to put, now since we want to get log 4 out of here, and we're going to, since we want to put that x, yeah, we're going to put over here log 4 to cancel that out, and basically put log 4 in the bottom, 7 on the other side. So x equals log base 4 7. And then again, you just do top on the top, bottom on the bottom. And for here, you'd put 2. First, we want to get rid of the 2. So we're going to divide by 2 here. 2, that's 2.5. So 3x equals 2.5. And do it again. Log 3, cancel that out. Log 3. And then basically you'd get x equals log 3 2.5. And then you do that again, the top and the top, bottom and the bottom. So log 2.5 log 3. Okay, and then you get 0.834. Okay, so now I'm going to, I guess, yeah, these ones are a bit different. So log 27 over log 3 plus log 16 over log 2. And then basically you can just simplify it. So first we can plug into our calculator first this one, log 27. So let's put log 27 divided by log 3 equals 3. And then you do the same for the other side, which will end up with a 4. And 3 plus 4 equals 7. Simple as that. And now 5 log 1 minus 2 log 10. Here you'd put 5 log 1 minus 2 log 10, because you're basically like separating it into the different parts. Log 1, if you put it into your calculator, will equal to 0. So you have 5 times 0 minus, and then log 10, if you put it into your calculator, will equal 1. So minus 2 times 1. And basically 0 minus 2 equals negative 2. So that's your answer. Okay, and it repeats like that. Let me see if there's anything that'll end up a little different. So yeah, so we'll do number 5. And then we'll skip on over to 7, 8, and 9. Awesome. Okay. So let's start this. 2 log 4x equals log base 4, 9. So let's again, we're going to get rid of that 4. We don't like that 4. 4's got to get out of here. And since you're both doing a 4, they're both like a common thing. Since log base 4 and there's a log base 4, you can just cancel both of those out. And now you don't have that problem. Great. 2x equals 9. Log x squared. Oh, right. Okay. So, along with canceling out the log, you have also, when you have a 2 outside the log, that means that it'll be x squared. And same thing, if there's a 3, then it'd be x cubed, and so on and so forth. So then you do that, x equals 3, and only the positive. You'd have a plus minus, but since we're doing logs, only the positive number. Okay, log base u2 plus 3u equals 1. Okay, so we have u2, since we're getting rid of the 10 over here, and 10 to the power of 1 over here, which will be 10. So you have u2 plus 3u. By the way, u2 is a great band. So then you have 10, and then you want to bring this on over to the other side, because again, we want to make it equal to 0 when you have a problem like that, where it's ax squared plus bx plus c equals 0. So u2 plus 3u minus 10 equals 0. And then what adds to 3 and multiplies to 10? That's to negative 10, 5, and negative 2. So u2, u2, no, u plus 5 times u minus 2 equals 0. So u equals negative 5, u equals positive 2. Okay, and then we have this monstrosity of a problem. Okay, so we're going to take the 5 out of here. And we're going to put the 5 over here. And yeah, so actually, you know what we can do? We can group it together, actually, first of all. Log base 5, x plus 6. Since it's also log base 5, we can just get rid of that. Log base 5. And then we're going to take 5 out of here. 5, because we're transferring it on over there. So x plus 6 times x plus 2 equals 5. And we're going to take that. So now we're going to expand it. So x squared plus 8x plus 12 is what you'll eventually get. Equals 5, and then minus 5 on both sides. So x squared plus 8x plus 7. And then we'll have what adds to 8 and multiplies 7. 7 and 1. So x plus 7, x plus 1. And so x equals negative 7, x equals 1. But you would reject the negative 7 because you can't have a negative log. And you'd also reject the negative over here. Whenever there's a negative, you reject it because logs don't like negative numbers. They always stay positive. Okay, so let's first do this part. Log 3x again, since they're both the same log, we can just combine them. Log 3x squared. Oops. X squared equals 3. Now we're gonna do that. Log 3x equals 3. Now we're going to put the 10 over here because log with no base is always log base 10. So we can just put the 10 to the power of 3 is 1000. So then 3x, and then we want to get rid of that 3. So we're going to put divided by 3, which is x equals 1000 divided by 3, which is equal to 333.333. And that's it. Awesome.